In this video, we'll talk about constructing models in QL to show that arguments are invalid. In the last video, we learned how to show that a sentence is contingent. Namely, construct two models, one in which it's true and another in which it's false. But what about arguments? Recall that the property that interests us for an argument is whether it's valid or invalid. To say that an argument is deductively valid means that it is impossible for the premises to be true and the conclusion false. To say that the argument is invalid, on the other hand, means that it's possible for the premises to be true and the conclusion false. To say that an argument is valid in QL means that there's no model in which the premises are true and the conclusion false. It's awkward to try and show that an argument is valid because it requires considering all possible models. We have to consider all of the infinitely many possible models and show that regardless of how they turn out, it couldn't be the case that the premises would be true and the conclusion false. To show that an argument is invalid, on the other hand, we construct one model in which the premises are true and the conclusion is false. It's called a counterexample model because it's a counterexample to the would-be validity of the argument. It shows that the argument isn't valid. That is, it's invalid. Consider this argument. For all x, mx arrow nx, nc, therefore mc. To give a model, we need to specify a universe of discourse, an extension for both the predicates that appear in it, and a referent for the constant. Let's try a universe of discourse with just one thing in it. It could be anything. For example, let's take the set containing the number 1. The referent of C must be a member of the universe of discourse, so it has to be 1. Now, to show that the argument is invalid, we need to make the premises true and the conclusion false. To make the second premise true, to make NC true, we'll have to put the referent of C in the extension of N. That is, we'll have to make the extension of N be the set containing 1. And to make the conclusion be false, to make MC false, we have to leave the referent of C out of the extension of M. Since there's only one thing in the universe of discourse, that means making the extension of M empty. We need to make the first premise true as well, but we specified the entire model. So we check. What happens to the first premise in this model? Fortunately, for all x, mx arrow nx gets a value of 1. It's true in this model. And that makes this a counterexample model. It shows that the argument is invalid because it shows how it's possible for the premises to be true and the conclusion false. Now consider this argument. For all x, px arrow qx, pe, therefore qf. This one's slightly trickier. We start out in the same way. We try out a universe of discourse with just one thing in it. And it gives us no choice as to the reference of E and F. They have to name something in the universe of discourse, and there's only one thing there for them to name. To make the second premise true and the conclusion false, we have to put the referent of E in the extension of P and leave the referent of F out of the extension of Q. So that gives us a model that looks like this. The problem is that this makes the first premise false. So the model doesn't do what we want. It doesn't tell us whether the argument is valid or invalid. It really doesn't show anything. However, the only choice we really made was to have just one thing in our universe of discourse. So let's try again with two things. For example, our universe of discourse can be the set containing the number 1 and the number 2. And now we have some choices about what to do with the reference. Should E and F name the same thing or different things? Let's try different things. Let the referent of E be 1 and the referent of F be 2. PE is a premise, so we need it to be true. To make PE true, we need to put the referent of E in the extension of P. QF is the conclusion, and we need it to be false. To make QF false, we need to leave the referent of F out of the extension of Q. Now, what about the first premise? For all x, px, arrow, qx. We can make it true by not putting 2 in the extension of P and by putting 1 in the extension of Q. Now, if you don't see this immediately, you can always try out different possibilities. After some trial and error, you'd end up with something that might look like this. This does what we need. The premises are true and the conclusion is false in this model. And so the counterexample model shows that the argument is invalid. This isn't the only possible counterexample model, of course. There are also models like this with 37 things in the universe of discourse, models with 1,000 things, models with infinitely many things. But this one, it's a simple model, and it's enough to show what we want to show. It shows that it's possible for the premises to be true and the conclusion false. So here's some advice. When trying to construct a counterexample, start with a really simple model. Add complications, like extra things in the universe of discourse, only as needed. In the previous example, we ended up building a model that didn't do what we wanted. But there are fewer choices to be made in models with small universes of discourse. And so you can try out possibilities quickly, see if they're going to work, see if they're not going to work, and if they don't work, move on and try something else. Trial and error in a large model with 37 things in the universe of discourse is more complicated and more troublesome. Finally, a point about notation. We've been talking about whether an argument's valid. We write the premises and the conclusion on separate lines, and we mark the conclusion with 3 dots that mean therefore. We can also write the argument in this way, on one line. This symbol between the premises and the conclusion is called a double turnstile. The double turnstile signifies logical entailment. It means that the sentences on the left-hand side logically entail the sentence on the right-hand side. Formally, that means that there's no model in which the sentences on the left are true and the sentence on the right is false. You can think of it as a symbol for validity. In a valid argument, the premises entail the conclusion. To sum up, you can show that a sentence is contingent or that an argument is invalid by constructing a model or two. The details are in what you want to have happen in those models. To show that a sentence is contingent, you need 2 models, one that makes it true and one that makes it false. To show that an argument is invalid, you need 1 model in which the premises are true and the conclusion is false. And the rest is just a matter of going in and by trial and error, figuring out how to construct the model that does what you need.